All right, once again, warm-up number 38 is on the screen. Number 1 reads, complete the square and factor. The polynomial given is x squared plus 20x. Number 2, it says simplify square root of negative 144. Number 3, it says add, subtract, multiply, and divide, and they give us 2 binomials. One of them in parentheses I minus 2, and the other one is parentheses I plus 3. And number 4 reads, find the inverse function f inverse of x for the given function f of x, and the given function is f of x equals x squared. So you should be able to do numbers 1 and 2 no problem. You should be able to start with number 3 with some of those. And hopefully some of you remember your noodle kicks in as to what to do with number 4, but I'll give you time and then I'll go over some of these, okay? All right, let's get work. All right, guys, so we have answers for numbers 1 and number 2. You should have gotten those 2 right there. And like I said, these were more of practice. But let me go over number 3, which is add, subtract, multiply, and divide those binomials right there. So I'm going to start with addition, and I'm going to do these 2 right here. So I got I plus 2, and, oh, hold on. I'm going to do it right here. I plus 2 plus 2, what am I doing plus 2 for a second? Yeah, so what I'm doing, guys, is I was going to do it over here on the side, but since I edit the video to just capture the center part of it, I need to move everything over here. So let me start all over. Add what? I minus 2 plus I plus 3. Okay, so let's see. Can I combine? Yes. What is I plus I? That is 2I. What is negative 2 plus 3? That's positive 1, and that's my sum. So we already did the addition. Let's go to subtraction. So I'm going to write I minus 2 minus, now look up what I'm going to do here. Look up. Parentheses I plus 3. So they're like, Mr. Q, how come you put a parentheses on the second binomial, not on the first? Look at it. Why did I put a parentheses on the second, not on the first? What do you think, Addie? What do you think? Why did I put a parentheses on this one?
Because we're subtracting.
And what does that mean?
Well, because that one's addition, it has to become subtraction, and since they're both positive, they have to become negatives.
Oh, I see. So basically, yeah, so she's right. She's saying these 2 become negatives, or in other words, if there's an invisible 1 here, we distribute that negative 1 to both terms here. So that becomes negative I and negative 3, and then we bring down the I minus 2. Let's combine. What is I minus I? They cancel. What is negative 2 and negative 3? That's negative 5. That's our difference or our subtraction. All right, let's go to multiplication. Multiplication, we just rewrite these. Parentheses, I minus 2 times I plus 3. All right, so here we go. I times I is I squared. I times 3, that's 3I. Negative 2 times I, that's negative 2I. And negative 2 times 3, that's negative 6. It's combined right here. So we're left with I squared. 3I minus 2I, that's 1I. And then minus 6. We'll stop right there, but once we get to this part of the session, which is coming up pretty quick, this portion is going to look a little bit different. There's an extra step that we can do here, okay? Yes, Mr. Q. All right, last but not least, let's do our division. Yeah, you guys love division. So we got I plus 2 divided by I plus 3. And once again, I'm bringing back everything that we've done. They're coming back, guys. So here we go. For my quotient, what number times I gives me 1I? Jeziel, focus. 1. So 1 times I is 1I. What is 1 times 3? That's positive 3. Okay. So what do we do next? We're going to subtract. What does that mean? That this is going to distribute. That means this is its opposite and the opposite. So this cancels. And we're left with -2 and -3. That's -5. And that's our what? Remainder. So let's write our quotient. So we got 1. But since we have a remainder, we get a fraction bar. There it is. Our remainder is -5. And our divisor is I plus 3. This is our quotient. How pretty, huh? Some cute merch for that, yeah. Bam. All I need is like a little, those neon colored lights in the back, and I'm gonna become like a vlogger, or what do you guys call those? Yeah, something like that. All right, and last but not least, number 4. It says inverse. So what is the first step? The process is the same. Change this to y form, and we get y equals x squared. However, next we need to isolate the x, or leave x by itself. And what did we do when we did the linears? We did inverse operations. So think about it. What is the inverse of squaring? Inverse of a square. What do you guys think? Inverse of a square.
Square root.
Bam, Danny, let's go. So if we take the square root here to cancel that, we need to take the square root of the other side. This cancels. We're left with square root of y equals x. I'm going to bring this over here. Rewrite it. Square root of y equals x. So once again, reminder, we started off with y form. Now we have x form, but we cannot leave it like that because we need to do the inverse. And what is the process of doing the inverse? Interchanging the variables. This one goes over here, this one over here. So our new equation is square root of x equals y. Now, can we leave it in y form? No, because over here, the original one was y form. That means this one becomes square root of x equals f inverse of x. There you go. All right. All right, so for today's lesson, you're going to need a Cornell note. Make sure you have a fair model. You're going to need 2 coordinate planes, guys. Make sure you get those ready, please. Okay. Here we go. Our objective for today, our agenda for today is warm-up number 38. Today we're still on transformation of functions, and tonight's home play is 2 transformations, and you're gonna make a video. You're like, what? Oh yeah. So tonight's home play is a video for 2 transformation, and I'll show you what to do in a little bit. So here we go. All right, your asynchronous code for tonight is J89VH. J89VH. For those of you that are new in our class, remember when you go to Nearpod, you write that code in there, and then you start off, it's asking you to log in. So then what you're gonna do, you're gonna type in the period number that you're in with me. So if you're in period 3, you would type 3 and then your first and then your last name, in that order, because I still have some of my students that keep saying period 3. No, I don't want to hear period 3. Just write the number 3, first and last name. Okay. All right. Next, your previous home play is on the screen, and that one you're going to turn in your asynchronous assignment. We're not turning it in Canvas today just to save time, because I want us to get to an activity. So that one, make sure you submit it on your asynchronous assignment. You're gonna need several pictures because there's gonna be several I believe. Okay. Next, your home plate for tonight. Here it goes. It reads, home plate. Do the indicated transformation to the following function. Graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. Then it says, part 1, graph g of x equals negative f of x plus 4, close parentheses, over 3. For part 2, it says graph g of x equals f of parentheses 1/2 x, close parentheses, plus 3. But then it says, make a video explaining how you got the final transformation for each part 1 and 2. Okay? So this is, here we go. I'm going to bring, let's see, where am I at? I'm right here. I'm going to bring myself in the picture. Here we go. So this is what I want. So basically, you're going to get your phone. Once you're done with those two, you have your notes in front of you. You're going to get your phone, and you're going to turn on your camera. And from there, it's on you, and you're going to start recording. Let's say I'm the student. I'm going to be like, yo, Mr. Q, here's Michael Jordan. And I'm going to go through my 2 problems so that you can see what I did on those problems. Let me switch cameras. Let me flip this. All right. Now I'm showing you my notes, and there's the first problem, part 1. This is what I did. I needed to do this, this, and that. And then from there, I did this for the table. And then from there, I went to do the last steps over here, and that's how I got my final transformation. For the other one, I did this, this, and that. And then I saw that it did this, and then my final thing was this, this, and that. And then let me switch back. All right, Mr. Q, well, I hope you enjoyed my video and you show this to everyone. Peace. And that's basically what I want, guys. I just want to make sure that you're understanding what we're doing. And because, you know, I've heard, not you guys, but I've heard some students, basically they just get the home plate already worked out from someone and they just copy it and turn it in as their own. What do you guys think? Not you guys, but I'm saying I've heard of it. It's a myth out there. So with this is going to tell me whether you understand it or not, because you're in the video and you're showing me. Let's go. I'm telling you, I got this. Man, Mr. Q, you got this. Oh, yes. All right.
Mr. Q, I have a question.
Yes. Yeah.
Is this going to be an assignment on Canvas that we turn in, or how are we turning in the video?
Yes, on Canvas. All right. You guys good? Yes, Mr. Q. All right. So let's move on. Our objective for today, I can transform a function using different parameters. We're still on the same objective. Today, we're going to complete this portion of transformations. I am going to have you guys do an activity, but just to get us started, once again, we're still transforming. We're still looking at the different parameters I introduced, but just to make sure, what is a function? In your own words, give me a definition, one example, one non-example, and a hashtag. Do that right now. I'll give you one. All right, so you should have completed that on your synchronous assignment. It's going to ask you to take a picture and submit. All right, where we left off last time, guys, we did the graph. It said the graph of f of x equals x squared is shown, and there it was. And then I briefly went through this portion. So today I want us to go over this one together. So go ahead and copy this parabola. The parabola has reference points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Do that on your coordinate plane. And then this is example 3, super Q, graph of f of x equals x squared is shown. And then it says graph g of x equals f of x minus 2, close parentheses, plus 3 over 2. And copy that, and then we'll go over this one together. It's going to go a little bit faster since we already did part of it last time. So I'll give you some time for that. Hurry up, please. All right, here we go. So we already copied the parabola. You should have that on your coordinate plane. And you have the problem already written. So let's do this part. Like I said, it's going to go a little bit faster just to make sure that we are caught up as to where we're at. And first things first, let me move this up a little bit. There it is. Okay. So first things first, I'm going to write my my form right here. And my general form is g of x equals a times f of. This time I'm going to show you including b. We got 1 over b x minus h, close parentheses. Since this is a quadratic function, I'm going to put the squared right there, and then plus k. So here's my parentheses. Here's my parentheses on this one. So I'm going to put a little square right here just to make sure it matches all the way through. Okay. Are we there so far? Yes, Mr. Q. All right, good. So last time when we left off, I said this looks kind of funky and we need to make it look like this, so like that we know exactly where we're headed. So in order to make it look like this, we needed to get rid of this 2 that's dividing the whole thing right here. And I said, well, if you look in front of the f right here, there's nothing there, but there's an invisible coefficient of 1. And I said, if we take that coefficient, including this 2, we can extract the 2 with the 1, and that becomes 1/2. Then I can write the rest, f of x minus 2 squared plus 3, and all that equal to g of x. Now, I'm going to explain what I just did here, because some of you last time, I guess it might have gone a little bit fast as to why I did this. Why did it become 1/2? Well, let me show you with numbers. So what I'm going to do over here has nothing to do with this problem, but it's going to explain as to why I'm able to do the 2 into 1/2. So if I was to give you, let me see, I'll do it down here. If I was to give you 8 divided by 2. 8 divided by 2, I can break this up and make it into 1/2 times 8. Do you agree with that? Let's see, 8 times 1/2 is the same as 8 over 2, which is, this would be 4. Now, why am I able to do that? Because it's the same as saying there's an invisible 1 here multiplying the 8, so 1/2 times 8. It's the same idea as to this. That's why we are able to get that 2 out of the way. Okay. So with that said, we know what each piece is. So let's see, what does a 3 correspond to? According to our rule here, it corresponds to K, and this one is going up. The 2 corresponds to our H, and it's going to the right. And what else will we have? 1/2 corresponds to A, and notice we don't have any B. So I'm gonna get this out of the way. Or B is equal to 1 because we need to have at least a 1 there. So B is 1. So there it is. It's an invisible 1. So this is A. So we need to worry about A. So I'm going to make a table with these 5 points. So we got X, f of X. The first point, -2, 4, -2, 4. Next one, -1, 1, 0, 0, 1, 1, 2, 4. Okay, so now that I have that, now let's find out what this multiplier will do to the entire function. So I'm going to add the column right here. And our multiplier is A, which is 1/2. And we're going to multiply that times f of X. And what is f of X? F of X are all these numbers, 4, 1, 0, 1, 4. So what is half of 4? 2. What is half of 1? 1/2. What is half of 0? 0. Half of 1? 1/2. And half of 4 is 2. So let's graph that so far, see what it did. -2, 2, -2, 2. -1, 1/2, -1, 1/2. 0, 0, 0, 0. 1 and 1/2, 1 and 1/2. And then 2, 2, 2, 2. I'm going to graph that in black because I'm still not done. So here's that parabola. And by looking at it so far, what did this multiplier do to the original function? What did it do to the original function? What do you think, Hayden? This is our original. What did it do? Hayden, you there?
Sorry, it compressed it.
It compressed it, yes. And for those of us that already see it, since it's a 1/2, it's a fraction, that's why it compressed this original one into this one. And at the end, what are we gonna do with all these 5 points, the red points? We're gonna move them 2 to the right and 3 up. So I'm gonna go start right here. 1, 2, 1, 2, 3. This one, 1, 2, 1, 2, 3. This one, 1, 2, 1, 2, 3. This one, 1, 2, 1, 2, 3. And this one, 1, 2, 1, 2, 3. And my final parabola, which is over here, I'm gonna label it g of x because that's my final transformation. It includes all of them. There it is. How we doing? Yes? Show me your fingers so I can figure out with these. 1 being the lowest, 5 being the highest. Yeah, 5, 5, 5s, 4s, 5s, yes. Okay, yeah, okay. So that, like I said, I wanted to recap this from what we saw last time, and we got this. Okay, let's go to the next one. Here we go. From there, after we were done with that, I said, I'm gonna introduce a new parameter, which is this one. And I said, here's the graph of f of x equals x cubed. And the reference points are -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So I said, today we're going to do the following transformation. G of x equals f of parentheses 1/2 x. So I want you to copy these points, guys. Make sure you copy this graph on the new coordinate plane and copy this problem. I'll give you some time and then I'll show you what we're going to do with that again. Like I said, I did some of it yesterday. I just want to make sure we finish that today. Copy that. So let me see. Yeah, let's go. Okay, so for this one, just to get our focus straight once again, I'm gonna go ahead and write my general rule right here. G of x equals a times f of, but this time I'm gonna include the b. I got 1 over b, x minus h. This is a cubic function, so I'm gonna put a little cube there, and then plus k. And notice here's a parentheses, and there's my cube. Okay. So by looking at it straight up right there, we see that this one doesn't have an a, or a is 1. There it is. It doesn't have an h. Look up. It doesn't have an h. And it doesn't have a k, but look, I'm going to include a k on this one just so that we can see it including the k. So I'm going to do minus, let's do minus 4, minus 4. Okay. So to find out what this is going to do to the original function, we need a table. So let's start, oh, and by the way, let's circle this one. This is our k because it's after the exponent. Here's the exponent. After the exponent's k. And that's going to take us which direction? It's going to take us down. Okay, we'll do that at the end. But we need a table with these 5 reference points so like that we can see what this half will do. So we're going to do x, oh, let me switch, x, f of x. So we got -2, -8. We got -1, -1, 0, 0, 1, 1, 2, 8. Okay, there it is. So let's find out what this is going to do. So we're going to add one more column for that multiplier. Remember, we did this on the previous session, and I'm going to write f of 1/2 x cubed. And we'll do the k at the end. So let's see what it does to the graph. But notice on this one, and I said, look up to the screen for those of you that you missed it. This one, notice the 1/2 is inside multiplying x. It's not outside as a coefficient multiplying f of x, which means we're not going to use this column of f of x. We're going to use all the x values to substitute in here in order for us to find out what the function's going to do. So I'm going to just do the first one. So I'm going to write parentheses 1/2 times, what is x here? X is -2. And at the end, I'm going to cube that. So let's see. -2 times 1/2, that's -2 over 2. And we're going to cube that. What is -2 over 2? That's -1. And what is -1 cubed? It's still -1. Okay, there it is, -1. That's the process. I'm not going to show you the rest because you already have it from the previous session. So here we go. Next value would be 1 or -1. So 1/2 times -1 is -1/2. So it would be -1/2 cubed. So that gives me -1/8. Next, 0 times 1/2 is 0. 1 times 1/2 is 1/2 cubed, which is 1/8. And last but not least, we got 1/2 times 2, that's 2 over 2 cubed, which is 1 cubed, which is 1. All right, let's graph that. We got -2, -1, -2, -1. There it is. -1, -1/8, -1, -1/8. Very close to the x-axis on the negative side. 0, 0, 1, 1/8, the 1/8 on the positive side, and then 2, 1. There it is. So I'm going to graph that in black. So let's see. So by looking at it, we said that what it did, it stretched it, but now it stretched it horizontally because that's what the B parameter does. But are we done? No, Mr. Q. What do we do at the end? We need to move all the 5 points. How many steps? 4 down. So from here I go 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. And this one, 1, 2, 3, 4. And now we do this one in black and in red. And this one we label what? G of x, because it's our final transformation. All right. And pretty much that's going to be the home plate, guys. The previous one and this one, they're just about the same. And once again, I want you to record yourself saying, Mr. Q, this is me, DJ Hernandez, and I'm going to show you what I did for this problem. Then you start recording yourself. From there, you go to your notes and show me what you did. Okay. All right. So with that said, from there, we get to this next part. This next part includes a general rule of all 4 parameters. We have g of x equals a times f of 1 over bx minus h plus k. Write it again, please, on a blank sheet of paper. And then I want you to write these next 4 questions, because we're gonna do an activity on DESMOS. And it says, let's explore. G of x equals a times f of 1 over bx minus h plus k. And then we have, for question number 1, it says, what does the graph look like when a is greater than 0 and a is less than 0? Pay attention to this part. Those of you that are doing something else, look up really quick. It says, what does the graph look like when a is greater than 0 and a is less than 0? So we're going to substitute values in here. But what does this mean? What kind of numbers are we talking about when a is greater than 0 and a is less than 0? Who's got it? What kind of numbers are we talking about? A greater than 0, a less than 0. What do you guys think?
Whole numbers?
Yeah, this is positive numbers and these are negative numbers. That is correct. Anything above 0 is positive, anything below 0 is negative. And that's the same question for all 4 parameters. You copy the same question, but now for b greater than 0 and b less than 0. Same question for h greater than 0 and h less than 0. And same question for k greater than 0 and k less than 0. I'll give you some time for that. Hurry up. And then I'm going to give you a code to go to DESMOS and answer that question using this activity. Now, for those of you that are watching on the YouTube channel, I'm going to stop the video right here. But I want you to answer those questions according to what we've done so far with transformations, okay? Because the code only works for live, the one I have that I'm going to give out for each of the periods, all right? So once again, if you answer those questions, you'll be fine. If you still have some more questions, make sure you see me in tutoring, all right? All right, for those of you in video, peace, have a good one.